Hola, chaps. This instructional video is for the benefit of the aerospace engineering students. I had given them an assignment. So ideally, we would have a reaction time exercise in the aerospace engineering course where one person holds out a meter stick, the second person catches it when it unexpectedly starts to fall, and then based on how far the meter stick falls, you can calculate what the person's reaction time, because we all know that we're on Earth. But what if you're at home and you don't have a meter stick and you don't have a partner to work with, or if you're in space in a spaceship where Earth's gravity is not affecting how long it takes something to fall? So, with only the equipment of a TI or equivalent graphing calculator, programmable calculator, I tasked my students to write a program that would measure the reaction time. And so, what I had in mind is that in my case, I'm using a TI-84 plus color edition, is that when you run the program, it would prompt you to start the program. Then it would wait a random amount of time, and I specified somewhere between 1 and 8 seconds. Wait for that amount of time to go by. And then unexpectedly put a um, message on the display screen, something that says like press now. And as soon as you see that message, as quickly as you can, press a key on the keyboard. And then repeat that a total of 10 times. And then calculate and display what is the person's average reaction time between when they first see the message displayed on a screen and they press the key as quickly as they can after that. So in this episode, I want to give you some guidance on how I would go about approaching this problem. There is a clock in the TI graphing calculator, and it measures in units of seconds. And that's not practical for what I'm trying to do with you. I'm trying to measure reaction. I'm trying to get you to write a program that measures your reaction time to within a hundredth of a second would be great. And a resolution of just 1 second isn't going to cut it. So I created this flowchart of how I would create a timing function within your programmable calculator. And I've already seen some students turn in some code that has a slightly different approach, but this is the one that I had on my mind, so this is one I'm going to share with you. So this doesn't do the whole program, but it does show you the approach I would use to have the calculator time how much time goes by. And so we'll try to do this as a little educational exercise for you. And so this is a flow chart. Those of you who aren't in aerospace might not recognize it. Somewhere I have a little template that I laser cut, but I haven't found it yet. It's in my debris called my office. But an oval is where you start or stop the flow of a program. Uh, and here I said the first thing you should do when you start this program is to clear any counter that you have, clear the screen on your calculator. Then bring up a menu, and the menu would give you two choices essentially. One is to start this timing program, and the second one is just to quit. So, menu choices. If you press the start key, so this diamond means make a decision, try to keep it one of only two possibilities. In the mind of a computer, this is either a true or a false condition. And if it's true, if you press the key that said start this program, then what I have it do is I have the calculator count as quickly as it can to itself, not displaying the answer, just internally doing a little loop that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, and so forth until you press any key on your keyboard. Okay? So once you press the key on the keyboard, display what number it reached as it counted to itself silently. And then once you've displayed that number, go back to the beginning of this program, clear that counter, clear the screen, bring up the menu again and say, well, hey, do you want to do another run or do you want to quit? And logically speaking, since I only had two choices here, if you did not choose start, then you must have chosen to quit. And so I have the program end on the second menu choice. All right. So I'm going to zoom out a little bit so you can kind of get the idea for it. Here is the entire program flowchart in one screen display. Hopefully the contrast is good enough, the screen size is good enough that you can actually see this flowchart well enough. Now I'm going to zoom back in. And so how do we do the specifics of this? Well, it would help tremendously if you were to get yourself something like the programming guide. What I found, donated from the math department, is an old Texas Instruments TI-82 programming guide. And I'm very happy with this because it reminds all of us that you don't have to have the most advanced model of the TI graphing calculator to do this exercise. We could almost even do it with a TI-81. I only have TI-81s in the science building on campus. So this is good enough. So good old TI-82 programming manual. That's what I'm going to use to create my instructions to do this. In the manual, it happens to have a little reference sheet about the functions of a TI. So I'm going to zoom in for a moment and say, gee, you should learn how to read this thing. So, I guess it starts alphabetically with A. So if you give it the instruction absolute value and then a value, it will return the absolute value of whatever it is you put in. So if you put in absolute value -5, it'll return a value of 5. And so here it is in alphabetical order. I'm going to scroll. I've already made an image of this. And so what I'll try to do is upload those images so you have this reference sheet that you can refer to. And I know I should pause when I scroll so that you have time to digest it or take a screenshot if you want. So alphabetically still going on. I'm going to use an if command. These are all commands. So eventually I'm going to be using the one that says if the condition is true, then do the command. It does have more capabilities than that. I'm going to be using the menu command. So menu starts off with first in quotes, put the title of your program or what the menu choices are. Then have a label, a text label of what happens if you press this choice. Next one, what label do you have if you press this choice? There's more on the back page. So here we go, continuing the alphabetical list. I don't see anything in this section that I'm planning to use. Nothing here. I was going to use display instead of output. I'm going to use the pause function. And the last page of alphabetical listing. I'm not planning to use any of these. I will use the stop function. There we go. All right. So if you do happen to well, that wasn't good. If you do happen to have a programming manual, then the section I'm in is on programming, input and output, a few things to know about. But let's see if I can kind of guide you through this sort of step by step. So the first thing we need to do is start creating a new program. So you power up your graphing calculator and you go program and you select new and now give it a name. Ooh, I suppose for this one is seconds, because all I want this particular routine to do is give me a calibration of how many counts does the calculator do to itself in 1 second of time. So I'll call this thing seconds. All right. The colon, if you've forgotten how to program or if you're one of the other course students, is a command line. And I see you can't see this. So I'm going to change things from now on and try to show the program displayed on the calculator a little bit better. All right. So I created a program called seconds. Of according to my grand plan, the next thing I was going to do is to clear any counters, clear a screen, and that means I'm going to write a program that says program. Let's clear the screen. That would be clear home. So you could either move the cursor down to whatever menu choice you want to select, or as a shortcut, if you just type one of these numbers before the colon, it'll automatically assume that that's what you want and select it and paste it. So I want to clear home. So if I just press the 8 button, it says, oh, you meant to copy and paste instruction number 8 on that menu of choices and enter. So the first instruction in this program is to clear home. And as I think about it, I really want the program to loop back to this first instruction. So when you edit this thing, there's no undo command. There's no save as command. There's only one copy of this program, and that's the one that you're currently editing. So I realized right away, I want to actually have the program always go back to the very first line of this program. So I'm going to move my cursor up, and on my keyboard, I'm going to choose to insert. So second, insert. And what that will do is insert a blank line above where my current cursor is located. So now I move the cursor up there, and I'm going to say, I want a label for this place, a destination for it to go to whenever I have to do something. So under program, under control, option 9 would be label. Boop. And the label I'll give it is 0, meaning I could pick a letter for a TI-84 Plus Color Edition. I can pick a number, and I'm just choosing what seems to me like a logical number choice that says, this is the beginning of the program. All right, so the first thing I do is I get up there and I clear home. Now I'm going to have a counter that I use where the calculator counts to itself as fast as it can. I can give that counter any name. In fact, I think on the TI advanced models, you can even give it a 2-letter name, but I'm not sure. 1 letter is good enough for me. And I is an old traditional choice of programmers for a counter. So I'm going to clear the value of the variable called I. So 0. Store is the button on the lower left here. This means take whatever value is currently in the calculator and store it into this memory location. So the memory location, I'm going to give it the letter A, so that means the alpha button. And the letter I'm choosing is the letter I, so I press what is now the green letter choice, enter, and that means on my display, I've created store 0 into I. So it doesn't matter what value I had before I did this instruction. This says set it to 0. All right, so I've cleared the display screen. I've reset my counter to 0. And those were the 2 first instructions I wanted to do. Clear the counter, clear the display screen. Now what? I'm going to put up a menu. And this menu is only going to have 2 choices right now. The first choice is to start timing, counting to itself. And the second choice is to quit this program. So back on my calculator, under program, I bring up a, where would that be? It's probably under control. So let's go back to control and scroll down. And sure enough, there's menu. So they ran out of digits. And now you can see if I press the letter D on the keyboard, that would have taken me directly to this menu choice and copied it and pasted it. All right, there's menu. You might have already forgotten what the format is for doing a menu, and I'm looking for the little cheat card I had already created. Here it is. So a reminder for menu, the format is, in quotes, have some title for this, comma, and then a title for the first choice, a label for where it goes to if you choose that choice, a title in quotes for the second choice, and a label for it to jump to for that second choice. So in that format, my title is, first of all, alpha lock, quote, what should we call this thing? Calibration, time calibration, seconds calibration. How about timing seconds? Timing seconds. Okay, so I need to get out of alpha lock, comma. So there's the title for this menu. And now I put in the text for the first choice. My first choice will be start. And if you like, start timing or start counting. I'll just say start. No, let's make it more. Start counting, because that's what it's going to be doing. C-O-G. G, quote, alpha lock, comma. Okay, so start counting. And where do I want it to go? I'll make that jump to a label called 1. And the second choice, quote, is quit. Once you start programming, you're going to want to be sort of repeatable and consistent in your word choices. So we'll call quit as choice 2. All right. So here's my menu. Its title will be displayed. It says timing seconds. When I press 1, it'll start the timing function. When I press 2, it'll quit the program. All right, so here's a command line prompt. What was it that I wanted to do next? Well, I wanted to see which choice I make. If I choose to start, then right away start counting to itself. All right, so it will jump to label number 1 if I make choice 1 off the menu. So under program, I need to tell it I'm now at label number 1, which is choice number 9. And this is label number 1, enter. So the menu will be displayed. If I press 1 on the calculator, it will take me to this instruction on the code. And the computer only does exactly what you tell it to do in exactly the order that you tell it. So what are we going to tell it now? We're going to tell it start counting to itself immediately. So the variable I is where it's keeping track of what number it has. So alpha I says, bring up the number that you've counted so far, add 1 to it, plus 1, and now store that number in itself, alpha I. So the way programming works is it executes the instructions on the left, which is add 1 to the current variable called I, and then store that new value in the variable called I. So the first time, I is equal to 0. Then it'll add 1 to that and store that as I equals 1. The next time it executes this program through this loop here, it'll say I is equal to 1. Add 1 to that. Now I have I equals 2, which it'll store. The next time, it'll be I equals 2 plus 1 stored as I equals 3. And so this is how the calculator will count to itself. The more instructions I put in here, the less often it's going to be going through this loop. It'll take longer in terms of actual time for it to get to this instruction. So I'm trying to create a very short loop here that basically just counts as quick as it can to itself and only asks itself one question every time it adds a number to it. And that is, have I pressed any key? So here comes the question under program, if. Now, how does if work? On the reference sheet, if said, if the condition, whoops, then do the command. And you can put it all in one line the way it's displayed here, but I'm not going to. So I want my condition on just, I like having the code on multiple lines. So what condition can I test? The one I'm choosing to use is called get key. So this doesn't really explain what get key does. So let me go to the manual for a moment and show you what the manual had to say about get key. And I suppose I have to zoom out a little bit so you can actually read the text, or I could read it to you. So it immediately tests the keyboard to see if you pressed any key whatsoever on the keyboard. And each key has a number code assigned to it. So you can see up here, the Y equals button is called button 11 or value 11. The cursors are 24 to the left, 25 up, 26 to the right, 34 down. So if you wanted to create a game where you're moving the cursor around on the keyboard, you would use get key that says, oh, you just press move right, and then have it, change the position of your character to the right until, so you're creating a program. So all the keys except the on-off key has a code with it, a numerical value. If you don't press any key, then, like it says here, whoops, fine print. If no key has been pressed, it returns a 0. So I'm going to use that as my test. As long as get key says 0, whenever I ask it, are you pressing a key? Then I want the calculator to just continue counting to itself. Later on, if you want to write a better program, aerospace engineers, for testing your reaction time, you could upgrade your code that says display some random number from 1 to 9 and time how long it takes you, the human, to press that particular key on your keypad. So if you told it, uh, if you had the computer randomly display the number 5 and then have the calculator timing, well, how long does it take for you to press the 5 key? Looking at this map here, the 5 key corresponds to code number 83. So you would have that as the get key test, and you would have to, do this appropriately to make it work out. And I would love it if you did something more sophisticated like that. But for now, I can go back to this program, which has shut itself off because I spent too much time talking. And I get back to this, and if, so what I'm going to test on is the get key itself, which would probably be, I don't know, it's either program or input output. It's input output. Menu choice 7. Okay, so that is sufficient right there. When this line of code executes, it will test to see if the get key has been pressed. Sorry, let me get it to where you can read things again. Yep. Okay. So if it's 0, which is false, then it will skip the following instruction. If it is true, which means you've just pressed a key, then you want it to execute this command that it's waiting for you to put in. And what command do I want to give it? I want to tell it to get out of this loop. So I'm going to tell it if a key has been pressed, then go to, and now I need a new destination. I've already used label 0. I've used label 1. I've used label 2. So I'm just going to call this one label 3. Go to the part of the code that begins with label 3. Now, it will only do this if a key has been pressed. That's what the if get key instruction is doing. So if a key has been pressed, then get out of this loop and go to the part of the code labeled label 3. What if the key has not been pressed? I want this to continue counting to itself quietly. And so tell it to go to where? Go to which label? 0, the top of the menu? No. Quit? No. To display the result? No. Okay, so I'm going to tell it to go to label number 1. And so now here's a very tight loop. At label 1, count to yourself until you, the human, press any key on the keyboard. If you don't press the key, go to label 1. Count to yourself until a human presses the keyboard. So this is a simple-minded loop, but I'm old school, and so here's how I'm going to do it. Okay, so this loop is count to yourself quietly, calculator, until human presses any key. Now, what do I want to happen next? So I need to tell it, here's the new section of code that you go to if a key is pressed. So label 3. Now, there are far better programmers out there than I am who would look at this construct and say, this is spaghetti code. This is where you have lots of labels and go-tos, and that's not elegant at all. You should use if or while or until. There are better choices to make. You're welcome to upgrade. This is just simple-minded stuff for those of us who don't program very much, or we're new to it, and this is something that you can maybe understand to start off with. Okay, so I will only end up at this section of the program if I've actually pressed a key. Now, what is it that I want you to do, calculator? So you've been counting to yourself all this while. What I would do is I would clear the screen, I suppose, although it probably doesn't need to be cleared again. Let's just move on with displaying things. So I'm going to choose option 3, display. Now, what's the format for display, you ask? Well, funny you should ask. It says here I could display value A, value B, so I could display the value of I. If we go to the programming manual, which, gee, you really should look up your programming manual and use it. It has a little bit more option. So you can display, let's see, where's my finger? You can display a message in quotes and comma, then the value. So I like this. Instead of just displaying a number, I display a little prompt that tells me what number is this that I'm looking at. So we're going to do this format. After display, no open parentheses, notice that. It's just some text message in quotes, then comma, and then the value that it's going to display. So back to the program, and I'm going to display a message, alpha quote lock quote. And here I could just say I space, and I'm doing second math test to bring up the equal sign. And then, by the way, it's not in alpha right now, so alpha space, alpha quote, comma, and now display the value of I. So alpha I, enter. The moment this message is displayed, I would like the program to just pause so I can look at it before anything else happens. So under program, I would choose menu option 8, pause. And the calculator will just wait here until you press the enter key on the keyboard. And then it will resume execution. So at this point, here's what we've done. We said, if you press start, then start counting to yourself quietly until you press any key on the keyboard. That was the if statement that says if get key. If get key is 0, that means you haven't pressed a key, and so just keep counting to yourself. Now we've displayed I, and we pause, and after this it says go back to the beginning of all this. So that was label 0. And so now that we are done looking at the value of I would tell it, go to 0, the very first instruction on this entire program. Okay, so that completes this entire section of the code. There's only one little piece left. And that is back on our main menu. What happens if I don't choose start? What happens if I choose quit? Right now in the menu, it said, if you choose quit, go to label 2, as I recall. So let's take a look at that and put in that part of the code and say label 2. So it will go to this line of instructions if you told it to quit. So when it's time to quit on a program, if you've changed things, like you've made it fixed format, radians instead of degrees, the window scale, this is the part of the code where you would say, okay, let me turn things back to the way I like having my calculator set up. Let me turn it back into degrees instead of radians, or normal notation instead of scientific notation. Whatever changes you made at the beginning of the program, this is the part of the program where you clean things up, wrap things up. And in this case, I don't have anything like that to do. So I would just go under program control and tell it stop, meaning this is the end of the program. Okay, so I've written this program. There's no undo, there's no save as. You'd have to go to memory management to make a copy of this program if you wanted to then edit a new version of it without changing this original. So I quit programming and I go to program and I choose menu option 8 seconds. Okay, so the program is now running and it says, here's my menu title, timing seconds, and start counting. So what I'm going to do here, all this is just to calibrate how quickly does the TI-84 Plus Color Edition count to itself. You will get a different result if you put the same program into a TI-82 or TI-81 or TI-83 or TI-84 Plus or TI-84. So the whole point of me showing you this little routine here is so that you would be able to write your own subroutine, basically, little program where you know much time, how quickly your calculator can count to itself. So for me to do this, I would have to know how much time goes by and then compare that. So I've got my stopwatch here, and then compare that with how much time it takes to uh, count that distance. So I'm going to try to time this for 10 seconds. So the same moment that I press start counting on my keypad, I'm going to press start on my illegal electronic timing device, which is now legal. Here we go. Start. 1 second, 2, 3, 4, 5, 6, 7, 8. Whoops. I accidentally pressed the key too quickly. So in a time of 7.59 seconds, I realized, oh, I touched the stop button on my phone, and it says in that amount of time, it had counted off to the number 897. Well, I want to do this for 10 seconds. So I'm going to reset my phone stopwatch, and this program is currently waiting for me. You can see the little indicator in the upper right-hand corner that says I'm pausing. Please press the enter key. Now that I've pressed the enter key, it resets the counter I to 0, and I'm back up at the main menu waiting to try this again. So here we go, ready to go. 3, 2, 1, start. 1, 5. So I tried to press the two keys simultaneously. On my stopwatch, it said 10.17 seconds. On My calculator, it said it counted to itself 105.5 or 1055 times in 10 seconds. So in my head, I divide this by 10. And so my conclusion is on a TI-84 plus color edition with a very small timing loop, it can count 105 counts, maybe 106 if you want to round up, 106 counts per second. Armed with this piece of information, you aerospace engineering students should now be able to go on and write a program around this that uses this as a way of measuring to the nearest hundredths of a second how much time it takes for you to press a key once a number has been displayed on your screen or an instruction that says press. So I want you to continue doing this assignment. A couple of you have already turned in your code, but some of you need a little more guidance. I wish I'd put this up earlier, but I'm going to post this today and extend the assignment. Those of you who are in chemistry and physics, you're welcome to learn how to program your calculators and acquire these skills. It's always useful to learn programming, no matter what kind of career you're going into. So play with your calculators, have fun with this, and good luck.